So today we are going to discuss about the diffraction process in ripple tank. And what is diffraction process? Because we already discussed about the reflection, which is bounce back of waves, and refraction, which is bending of waves, right? So in diffraction, waves are going to be reflect or refract through the, there is something different in diffraction, that waves are going to be refract or reflect through the edges. So edges of obstacles, right? Which are going to be placed in the path of waterways, right? Okay.
Yes.
So in this process, now waves are going to be reflect or reflect through edges of obstacles, which are going to be placed in the path of waterways, right? So इससे पहले जो हमने रिफ्रैक्शन और रिफ्लेक्शन देखा, उसमें ऐसा कोई फिनोमिना नहीं था, उसमें कंप्लीट वेव्स जो है वो कोलाइड कर रही थी, ट्रांसफर हो रही थी एक मीडियम से दूसरे मीडियम. एंड इन डायफ्रैक्शन देयर इज अ स्लाइट डिफरेंट ओरिएंटेशन of reflection or refraction. So let's now illustrate a diagram of diffraction. And there are two types of diffraction, or you can say that there are two possible states of diffraction in ripple tank. Let's suppose if the obstacles are going to be placed in this orientation, right? And in our second example, obstacles are going to be placed with very narrow gap between them, right?
Yes.
So this is our situation number one. This is our situation number two. You can easily differentiate these situations because in first one, there are sharp edges, and in the second one, there is a narrow gap between obstacles, right? Okay, so now let's suppose water waves are going to be travel. So water waves are going to be travel from left to right towards the direction of obstacles, right? So what will be the orientation of wave after passing through the obstacle? Any idea?
Will it spread in all directions?
Okay, it will spread in all direction. Very good. So the orientation will be like this. So you need to draw at least 3 lines after passing through the obstacle. So waves are going to be spread in all directions like this, right? And if we want to observe same phenomena in the second situation, so how waves are going to travel from the obstacles? Any idea?
No, sir.
Okay, so waves are going to be in semicircle form or shape after passing through the obstacle, right? So you have to remember these types of orientation of waves after passing through obstacles in diffraction process, right? Any confusion?
No.
Okay, so this one is for narrow gap. when gap is very narrow between the obstacle. So you need to draw semicircle waves, and in this one, sharp edges or a wider distance between the obstacles, right? So now you can solve more questions. So our new chapter is of sound, which is also links with the general properties of wave because sound is also a wave, right? And in which category sound normally categorized, either sound is longitudinal or transverse, because we already discussed about this, that sound is a longitudinal or transverse.
A longitudinal?
Longitudinal, very good. So sound is longitudinal in nature. So if sound is longitudinal, so it means that sound also requires some medium to travel, right?
Yes.
So it requires some medium to travel. So these are basic two terms or basic two phenomena related to the term sound. It requires medium to travel. And what are the other properties? Anything about sound? If we want to discuss about the speed of sound, or let's suppose if we want to discuss about the process which are going to be happen in the sound waves, we discuss about the process in the spring or in the sound wave in previous chapter, that there are two types of process. Do you remember that process in longitudinal wave?
Compression and rarefaction?
Compression and rarefaction, zabardast. So compression is the first one and rarefaction is the second one. So these processes also involve in the sound wave. Rarefaction, okay. We already discussed about the rarefaction and compression, that in compression particles are going to be close to each other, and in rarefaction particles are going away from each other, right? Okay.
Yes.
So if we discuss about speed of sound, if we discuss about speed of sound, so what will be the speed of sound? Any idea? Any guess?
It's slower than light?
Yes, it's lower than light. Very good. So the speed of sound will be equal to 330 meter per second. There is a range of speed of sound 330 to 350 meter per second, right? So this is the speed of sound. It is also mentioned in your syllabus and in your book, that speed of sound is going to be between 330 to 350, and there is a difference of 20 meters per second in the speed of sound. Can you identify that difference? Why actually the difference is there in between these two values?
A difference of medium?
Difference of medium, right? Another, any other option or any other factor?
I'm
There,
not sure.
okay, let's suppose if we take our daily life example. So in daily life example, in our atmosphere, there are only air molecules, right? We normally experience speed of sound in air. Okay. So if we take the example of air molecules, or let's suppose if we are going to discuss about our atmosphere, so in our atmosphere, there are only air molecules, right? or you can say that there is only air medium around us, and there is also a change in the speed of sound. So why this change happens in the speed of sound? That is happen, or that could be happen because there are some changes due to the temperature, right? Because temperature might be low the night and high in the summer days, right? So there is also a factor of temperature, because when the temperature is going to be high, so the kinetic energy or the energy of the molecules are going to be increased, right? You study this concept in chemistry also. If we increase the temperature, so the energy of the molecules will also increase, right?
Yes.
Let's suppose if we discuss about the example of boiling water. So when we start boiling water, so water molecules gains energy, right? And then after the bubbles going to be make in the water, which represents that water molecules are getting some energy, right? So the difference between these speed of sound is due to the temperature and due to the air pressure, right? So these are the factors which actually makes speed of sound variable in air medium. Okay, we don't need to discuss in detail it because this is not our part of syllabus. Just need to know about the difference in speed of sound, that why there is a big difference of 20 meter per second in the speed of sound, right?
Yes.
Okay, so this is for speed of sound. So after discussing the speed of sound in air, what about the other mediums, right? Like solid, liquid, and gas. So if we compare the values in different mediums, so let's suppose starting with the solid one. So if we compare the speed of sound in solid, in liquid, and in gas, और अगर आपने यहाँ पर स्टार्स की तरह जिस तरह हम रेटिंग्स देते हैं आपको, आपने यहाँ पर रेटिंग्स देना हो, तो आप रेटिंग्स देकर बताओगे कि कहाँ पर स्पीड ऑफ साउंड जो है वो ग्रेटर होगी। आपने 3 स्टार देने ग्रेटेस्ट को, 2 स्टार्स देने मीडियम को, 1 स्टार देना लेस को, राइट? So now
Yes.
let's try to rate these matters or mediums with the reference of speed of sound. So what do you think that in which medium speed of sound is going to be the greatest one?
Gas.
Okay, you do that gas, like you are saying that in air, right?
Yes.
So you give 3 stars to the gas. Okay. And if we discuss about the 2 stars rating,
Liquid.
liquid, क्योंकि liquid बीच में लिखा था उसको 2 स्टार ही दे देते हैं. Okay, if we discuss about the solid, so solid got only 1 star, right?
Yes.
So this is your assumption that sound might be travel fast in gas and slowest in the solid, right?
Yes.
Okay, but in actual or in real scenario, there is something different in the speed of sound related to these values. And what is the difference? If we consider the example of solid first, right? And if we discuss about the structure of solid molecules or some solid object, that in solid molecules are tightly packed with each other, right? And
Yes.
they can only vibrate from their position, right? Because they don't have enough space to move from one place to another. So they only vibrate from one point or some distance from their positions, right? And since sound wave is
Yes.
longitudinal in nature, so it means that they require some medium to transfer energy. And if we want to transfer energy from one molecule to the other molecule in solid, so it will be easy or difficult to transfer energy from the first molecule to the last one. Any idea? Because in solid, molecules are tightly packed like this, and you need to or you have to transfer energy from the first one to the last one. So will it take less time or greater time to transfer energy?
Less than.
Less time, because these are very tightly packed, so energy will transfer more rapidly, right? So that's why solid takes less time to travel. And the reason is this, that molecules are tightly packed with each other. Molecules are packed with each other, right? So that this is the reason they transfer energy. They transfer energy in short time or in less time, right? So this is the scenario for solid, right? Now discuss about the liquid. So if we discuss about the liquid, what will be the speed of sound? Either is it greater than solid or less than solid now?
Less than solid.
Yes, less than solid, because in liquid particles are far away from each other as compared to the solid objects, right? So molecules are at some distance as compared to the solid objects. So if we want to transfer energy in liquid molecules, so it takes some time or greater time as compared to the time taken by molecules in solids, right? So we can say that molecules are away from each other, so they transfer energy they transfer energy slowly as compared to solid, right? Okay, Veer, any
Yes.
confusion?
No.
Okay, so this is basically the general properties of matter of three states. So this is for solid, this is for liquid, and what about gas? Molecules are far away from each other, they are moving in random direction, right? Because liquid have if we contain liquid in some container, so molecules can only move in the range or in the region of that container, but gas molecules are free to move, so we cannot contain that gas anywhere in our atmosphere, so they have many, or you can say that greater space to travel from one point to another. So in gas, molecules are far away from each other, and if you want to transfer energy from one point to another, So it takes greater time as compared to the molecules of liquid, right? Because molecules are away from each other, so they take much time to travel or transfer energy from one point to another. Any confusion?
No.
Okay. So molecules are far away from each other. So that's why the transfer of energy becomes slow as compared to the liquid, right? So now again
Yes.
try to rate these matter of states with the reference of speed of sound. So which matter will got 3 stars?
Solid?
Yes, solid will get 3 stars for the speed of sound, and you know the reason, right?
Yes.
Because when we strike a solid object on, let's suppose someone strikes a pen or a ruler on the desk of the classroom, the sound will travel more rapidly, right? If we apply some little force on it, so sound will travel more rapidly as compared to the other object. And liquid will be in the middle of solid and gas, and in gases, sound will move with lowest speed as compared to the solid and liquid, right?
Yes.
So this is the basic concept of speed of sound related with the different states of matter, right?
Yes.
So if we discuss about the factors on which sound is going to be depend, so the first factor on which sound depends is of loudness, right? So basically loudness is a factor which help us to distinguish between, or you can say that it help us to differentiate between loud and a faint sound, right? तो loudness आपको ये allow करता है कि आप एक loud और एक faint sound में difference कर सको, इस property को हम कहते हैं loudness, right? So if sound is going to be loud or sound is going to be faint, so which property is going to be linked with the loudness of sound? Is it frequency? Is it wavelength? Is it amplitude? Or is it time period? Any idea?
Frequency?
Frequency, okay, but frequency is not actually linked with the loudness, but you tried. Uh, Loudness basically links with the property of amplitude, right? So loudness is directly proportional. Do you know the concept of directly proportional?
Yes.
Okay. Directly proportional, the amplitude, right? The greater the amplitude, the louder will be the sound, right? Because when we draw a wave or a pattern of a wave, hmm, so if we draw a wave like this, So the maximum height or the maximum depth represent the amplitude of a wave, right?
Yes.
So if two waves are there, so you can easily identify with the help of amplitude that which wave or which sound is the louder one, right? So loudness is directly proportional to the amplitude, which means that louder sound is directly proportional to the amplitude. If we increase the amplitude, we will get the louder sound, right? And if
Yes.
we decrease the amplitude, we will get the faint sound, right? Any confusion?
No.
Okay. So now let's discuss about the second point or the second factor, which is of quality, loudness, and pitch. So second factor is of pitch. And first of all, let's define what actually pitch is. So pitch help us to differentiate between it help us to differentiate between any guess. So basically pitch help us to differentiate between shrill and a grave sound, right? And what is a
Yes.
shrill sound? What is a shrill sound? If we compare the yes,
A grave is a loud, a deep sound.
yes, very good. And what about shrill? A sharp
It's like
noise.
noisy.
Yes. So if we compare the sound of our voice, so इसकी आवाज जो है वो shrill और grave होगी. If we want to compare the sound pitch of our sound voices, so which voice is going to be shrill and which voice is going to be grave? Any idea?
I'm not sure.
Okay. So normally it happens that the voice or the sound of a child or females or a girls are slightly shrill as compared to the voice of men or the old men or the boys, right? Not in all cases, but majority, 90% you say that the voice of women, girls, and a child are shrill one, right? A sharp noise. And the man or the boy or the old age person normally have a grave sound, right? A heavy sound. Okay. So your voice is
Yes.
shrill and my voice is grave as compared to your voice, right? So Abhi has
Yes.
shrill sound and my voice is grave one. Or if we want to discuss the factor that how can we identify that which sound is going to be shrill? So which factor is going to be linked with the pitch of a sound?
Sir, is it frequency now?
Yes, it is frequency now. So frequency is the factor. So if we increase the frequency, so sound will be shrill or grave.
Shrill?
Yes, very good. Sound will be shrill or the sharp noise. Shrill means a sharp sound or sharp noise. And if we decrease the frequency, sound will be grave, and which means a deep sound, right?
Yes.
So this is an other factor which is linked with the frequency of wave, right? So greater number of waves in 1 second makes a shrill sound, right? And less number of waves in 1 second, sorry, make a grave voice or a grave sound, right? Any confusion?
No.
Okay. Shall we discuss another factor? बहुत ज्यादा burden तो
Okay.
नहीं हो गया?
It's fine.
So the third factor is of quality of a sound. We normally use this word in our daily life for different products, different mobile phones, speakers, that the quality of that phone, quality of that AirPods, quality of that speakers is good, bad, right? So what actually is the meaning of that word quality in sound, right? Let's suppose if there are two sound going to be produced at same time, basically this factor help us to differentiate it help us to differentiate between it help us to differentiate between two sounds of same loudness and same pitch, right? So the above factors we already discussed. So this third factor will help us to distinguish between two sounds of same loudness and of same pitch, right? So let's consider the example that how can we distinguish between these two sounds of same orientation. Let's suppose if there is a sound of piano, right? So first of all, let's discuss the example of piano and try to draw a waveform for the piano. So let's suppose the wave for the piano is going to be like this. Do you feel any difference in this wave?
Yes.
This wave is a wavy type or the shaky one, right? And if we discuss another example, let's suppose if we discuss another example of fluid, because these both are the source of sound. And if we want to draw the wave in this, so wave is going to be somewhere like this. So these two sound waves are, let's suppose, same in loudness and same in pitch. So now how can we identify the difference between these two sounds? Any idea?
No.
Okay. If you observe that there is a different shape or different orientation of waves in both examples, right? Piano has some wavy type or shaky type of wave, right? And fluid have somewhere shaky and somewhere smooth, right? Let's suppose this part is shaky one, this is also, and somewhere it is smooth. right? Which means that there is a difference of orientation in the waves of these two sound sources, right? And if we observe the wave of the piano, so there is a wavy like shape in piano, right? So this is the difference between these two sound waves, right?
Yes.
So we can say that quality help us to distinguish between two sounds of same loudness and same pitch, and the factor which help us to distinguish this property is known as waveforms, right?